Today we are going to discuss about the column Euler's splitting load for column one end is fixed and the other end is hinged. So this we are going to discuss right now. So first of all, so the column have fixed end here is at A and hinged end at B. Okay. So the load is going to act here. So this is nothing but crippling load. So the concavity is going to happen here. Okay. So because of this fixed end, we can have one end moment here, MA. Okay. So this MA, how it can create now? Because of our horizontal force. Okay. So the total length of the column is L. Okay, the total length of the column is, we are going to take it as a L, height of the column. Okay, and the deflection at the section X, we are going to take it as a Y. Okay, now we have to calculate the what is the crippling load value that we are going to calculate now. Okay, so first of all, we have to write something. Okay, now so whatever the content we have shared now, that we have to write in the form of written statement. Okay, the column. So the column of length L, the column of AB. Okay, now the column of AB length L, the end A is fixed and the end B is hinged. Okay, here the height, the crippling load is acting at point B or column end B. Okay, now so due to that the deflection at X from A is denoted as Y. Okay, now so these things we have to write it, and the end moment, the fixed end moment MA is occurred due to the horizontal force H acting at the hinged end B. Okay, now the Euler's crippling load we have to find out. Okay, so we should go for the next page. Okay, so now the moment. Okay, the moment acting at a distance of X. Okay, so moment M, we know that here there are two moments. Okay, one is because of force P into Y. Okay, now Another, with respect to the horizontal force, the moment is acting. That is h into L minus x. So here the distance. Okay now. So now we are going to write that. So the moment, okay, m is equal to minus p into y. So the minus sign is because of concavity. Okay, now we already seen this. Okay, now the sign conversion. Next, with respect to horizontal force, h into L minus x. So we all know that, okay, moment m is equal to ei into d squared y by dx squared. Okay, now equating these two terms. Okay, equating the above two terms. So ei into d squared y by dx squared is equal to minus p into y plus h into L minus x. Okay. Now we are going to written as ei into d squared y by dx squared plus p into y is equal to h into L minus x. Once again, I am going to rewrite this equation, that is divided by ei. So if I am going to give divided by ei, d squared y by dx squared plus p by ei into y is equal to h into L minus x by ei. Okay. Now the solution for this equation, that is d squared y by dx squared plus alpha squared into y is equal to some terminologies here. Okay now. So for this, the solution for this equation, we are going to denote that the solution for the above equation is, okay. So the solution for the above equation is nothing but y is equal to c1 into cos uh, there is x into alpha x, okay, plus c2 into sin x into alpha plus the terminology a. Okay now. So here, how the way we are going to take it now? Mm, so here alpha squared is equal to p by ei. So alpha is equal to root under p by e as per our term. Okay, now. And here without p, the equation is available. So we are going to divide by p. Okay. So it becomes h into L minus x divided by p. Okay, the term becomes now. So how the way we are going to write y is equal to c1 into cos x into root under p by ei plus c2 into sin x into root under p by ei plus h by p into L minus x. Okay. So this is the term which we are having right now. So the solution for the equation is y is equal to c1 into cos x into root under p by ei plus c2 into sin into x into root under p by a plus h by p into L minus x. Okay. So this is the equation for the above, the solution for above equation. Next, what we are going to do means the boundary condition we have to substitute. The boundary conditions we have to substitute. Okay. Substitute to get the constant values. To get the constant values C1 and C2. So the boundary conditions The boundary conditions are, okay. So come to the first slide. So here the end A is fixed. Okay, now if it is the fixed end, then the deflection is equal to 0 and the rotation is equal to 0. That is, slope is equal to 0. So this is one condition. And if it is hinged end, okay, now the deflection will be equal to 0. So these three conditions as going to use as the boundary condition. Okay. So now the boundary conditions are at x is equal to 0, then y is equal to 0. Similarly, at x is equal to 0, slope dy by dx is equal to 0. Okay, now, so this another condition at x is equal to L, then y is equal to 0. So these three are the boundary conditions we are going to use to find out the values of constants C1 and C2. So now let us substitute the values. Okay, so first equation. So first boundary condition. First boundary condition we are going to use. That is at x is equal to 0, then y is equal to 0. Therefore, the equation 1 becomes, so y is equal to 0, then C1 cos 0 plus C2 sin. So if I'm going to substitute x is equal to 0, the entire term becomes 0. Okay. So cos C1 cos 0 plus C2 sin 0, C2 sin 0 plus h by p into L minus x. So f I'm going to substitute as 0. Okay. Then cos 0 is equal to 1. We know that cos 0 is equal to 1. Sin 0 is equal to 0. Okay. So if I'm going to substitute this, C1 I can have. Okay. C1 plus this entire term becomes 0. So this term becomes 1. Okay. Now, so C1 plus h by p into L. Okay. Therefore, C1 is equal to minus h by p into L. Okay. Next, we have to find out or we have to use another boundary condition. Okay. So the next boundary condition is second boundary condition is that is at x is equal to 0, then slope dy by dx is equal to 0. Okay. So here dy by dx we have to calculate. Okay. So first y is equal to what it is c1 cos x into root under p by ei plus c2 sin x into root under p by ei plus h by p into L minus x. Okay. Now we have to differentiate with respect to x. So dy by dx is equal to first the whole term. So c1 minus sin into x into root under p by ea. Next term, the x into root under p by ea. So if I am going to differentiate, I can get root under p by ea. Okay, plus c2 into cos. Okay, x into root under p by ea. Next term, if I am going to differentiate this alone, then I can get root under p by ea. So this equation I'm going to write it as h by p into L minus x. I'm going to write it as h by p into L minus h by p into x. So if I'm going to differentiate this L term is going to 0, nothing is there. This term only we can have. So minus h by p we can get. So this is the equation we can have with respect to the dy by dx. Okay, that is slope equation, dy by dx. Okay, now in this equation, we are going to substitute x equal to 0 and dy by dx is equal to 0. Okay, we should move on to do this. Okay, so now dy by dx is equal to minus c1 sine x into root under p by ei into root under p by ei plus c2 cos x into root under p by ei into root under p by ei minus h by p. Okay. So in this equation, we are going to substitute the second boundary condition. That is x is equal to 0 means dy by dx is equal to 0. So if I'm going to substitute this minus c1 0 into root under p by e. So sine 0, correct? Plus c2 into cos 0 into root under p by ea minus h by p. So this term becomes 0, okay, because of sine 0. So remaining thing we can have c2 into cos 0 is 1. We know that cos 0 is equal to 1 and sine 0 is equal to 0. Okay. So plus c2 into root under p by ei minus h by p is equal to 0. So this equation I am going to write it as c2 into root under p by ei is equal to h by p. If the term comes to left side. Okay, now c2 becomes h by p into, okay now, so this term it is going to be a divided question, so it will become ei by p. So this is the value of c2. Okay. Now we can have the another equation, that is if x is equal to L, then y is equal to 0. That equation we are going to substitute now. Okay. Then we should move on to the next page. Third boundary condition. So third boundary condition. At x is equal to L, then y is equal to 0. So we know that y is equal to c1 sine x into p by ei plus c2 into cos x into root by p by ei, then p plus h by p into L by x, h by p into L by x, h by p into L minus x. So now I am going to substitute x equal to L and y is equal to 0. Meanwhile, C1, C2 value. So C1 value minus HP by L. C1 value is minus HP by L. Minus H by P into L. C2 value is H by P into root under EA by P. H by P into root under EA by P. Okay, now? So these values we are going to substitute in this equation. The above equation. So x equal to L, y is equal to 0. So y equal to 0, C1 minus h by p into L into sine L into root under p by ei plus C2 h by p into root under ei by p into cos x L root under p by ei plus h by p into L minus x is equal to L. So this term becomes 0. Okay. Now only the thing is available is minus h by p into L into sine L into root p by ei plus h by p into root under ei by p into cos L into root under p by ei. So in this term, h by p is common. So if I'm going to take it outside, Then if I'm going to go for left hand side, then the term becomes 0. Okay. So it is going to 0. Okay now. So only the thing available is minus L into sine L into root under P by EI plus root under EI by P into cos L into root under P by EI. Okay. Now this term I'm going to this side, left hand side, and this term becomes right hand side. Okay. So how we are going to change L into sine L into root under P by EI is equal to root under EI by P into cos L into root under P by EI. Okay. Now this term is going to be here and this cos term going to be here. Since sin by cos we know that tan. Okay. So tan into L into root under P by EI is equal to root under EI by P the whole term divided by L. Okay. I think I have done anything wrong. So now this term we are going to write it as a, so this term we are going to write it as a L into root under P by EI. Okay. So which is nothing but tan L into root under P by EI is equal to L into root under P by EI. So this is the term we are getting now. Okay. The solution for this equation is the solution for the above equation is L into root under P by EI is equal to, that is the tan particular value is equal to same value we have to get it. Okay now. So this I'm going to get it as in 4.5 radians. Okay, this value we have to remember. Okay. So there is no way. So L into root under P by is equal to the same value means that is 4.5 radians. Okay. So next what we have to do, we have to do the squaring of both the sides. Squaring of both the sides. So the equation becomes L squared into P by EI is equal to 4.5 squared, which is nothing but around 20.25. Therefore, P is equal to 20.25 into EI divided by L square. So this 20.25 we are going to denote it as pi squared into, that is 2 pi squared is equal to 20.25. So that we are going to write it. So P is equal to 2 pi squared EI by L square. So this is the equation for Euler's crippling load. For the column, one end is fixed and another end is hinged.